Hey my lovely level 3s, and welcome back to 3.4 Atomic Structure and Bonding. This is lesson 10 part B on the polarity of molecules. So the only thing that I'm wanting to go through during the second part of the video is I'm wanting to run 3 examples of why they're polar or non-polar. I've typed up the answers, but we're going to do Lewis structures, the shape, describe the shape, and we're then going to describe the polarity. So hopefully this will bring everything together for a lot of you. So we're going to start with SF4. Now I'm going to do the Lewis structures and shapes on this slide, and I'll discuss them all, and then you can read through my typed up answer. Okay, so group 16 and 7 times 4, and that gives us 34 electrons. S is going to be in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and then the extra pair go here. So therefore that's the Lewis structure done. Okay, 1, 2, 3, 4, and 5 electron density regions there. And because there's 5 and there's one lone pair, we know that this is taking after the parent geometry of trigonal bipyramid, but the one lone pair means that the shape is going to be seesaw. So I'm going to draw that with my T being in the plane. Okay, and then I'm just going to draw one bond coming down for this F, and then you can put the lone pair in if you want. Okay, and so this shape is seesaw with one missing. Okay, I know here the three-dimensional shape doesn't really look like a seesaw, but if I just grab out my trusty little makeshift molly mods to show you, so this is trigonal bipyramid with 1 up and down in the axial position and 3 in the equatorial plane. If you remove 1, then it looks like your little seesaw. Okay, so hopefully that makes sense. This is just the easiest way to draw it to keep it consistent. So what we're going to do now is we're going to discuss the shape, and I'm not going to write it all out because it makes the page really clunky, but hopefully you can follow through with me. Okay, so SF4 has got 5 electron density regions around the central S atom. These repel as far as possible, and they create a parent geometry of trigonal bipyramid. Okay, there are 4 bonding and 1 non-bonding pair of electrons, and so the shape is seesaw. So I've justified the shape. There are 4 S-F polar bonds, okay, and that's because F is more electronegative than S. Okay, this shape is not symmetrical due to that lone pair. The dipoles do not cancel, and this structure is polar. So I hope that makes sense. I'm just going to draw the polarity in for those who might be confused. So because F is more electronegative, it's slightly negative. S is slightly positive, slightly positive, slightly negative, slightly negative, slightly positive, slightly positive, slightly negative. So what you can see here is the fact that the dipoles do not end up cancelling, because what happens is you end up with this part of the S having an overall charge, which is the fact that the S ends up being a bit positive, and so you've got one side of the molecule slightly negative and one side slightly positive, and so that means that the structure is polar. You don't need to describe it like this, you just need to understand that because there's a lone pair, the dipoles can't cancel out, so this F can't cancel with anything over here, and so you end up with a bit of a dipole. Cool, so I hope that makes sense. So now we've got Br, F3, and so all of these are group 17, so that gives us a total of 28 electrons. Bromines in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so there's our Lewis structure for BrF3. Okay, there's 1, 2, 3, 4, 5 electron density regions. So 5 electron density regions. So the parent geometry here is trigonal bipyramid again. There are 3 bonding and 2 non-bonding. So our shape is in fact T shape, which is a nice easy one to draw. It's all in the plane of the page like so. So I've just lost these 2 pairs here. So I hope that makes sense. So now we're going to justify the shape and polarity. So BrF3 has 5 electron density regions around the central Br atom. These repel as far as possible, giving a parent geometry of trigonal bipyramid. There are 3 bonding and 2 non-bonding pairs of electrons, and so the shape is going to be T-shaped. There are 3 times polar Br-F bonds because F is more electronegative than Br. Okay, the shape is not symmetrical and therefore the dipoles do not cancel and the shape is polar. And that's the end. Okay, last one, CrF2, 8, 7 times 2. So that gives us a total of 32 electrons. Is that right? I don't know if I've added that right. 14 plus 8, no, 22. I think that's right. Okay, so if we put this in the, this in the middle, okay, and we'll do 1, 2. Okay, so we've used 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So you've got 1, 2, 3, 4, 5 electron density regions, okay, which means that the parent geometry is trigonal bipyramid. There are 2 bonding and 3 non-bonding, so the shape is going to be linear. Now this linear shape, despite the fact that there are lone pairs, the lone pairs all cancel out with each other, and so therefore this shape is symmetrical. Okay, so let's just go through. Let's justify first of all. So CrF2 has 5 electron density regions around the central Cr atom. These repel as far as possible, creating a parent geometry of trigonal bipyramid. There are 2 bonding and 3 non-bonding, so the shape is linear. There are 2 polar CrF bonds, as F is more electronegative than Cr. The shape here is symmetrical, and therefore the dipoles cancel, and therefore the structure is non-polar. Now I hope that all makes sense. If you have any questions, you can please put them to me on Teams. I'm just going to go through slowly and pause, and that's the end of this video. So this is SF4. Okay, you can pause. This is CrF2, you can pause, and BrF3, and you can pause. Apologies, these are in a different order. Okay, I hope that's all made sense on polarity. You're halfway through the topic. Very well done, team.